Hello and welcome to week 5, lesson 1. We only have 2 lessons this week. Therefore, these videos are going to be just a bit longer. So we're going to look at classifying polynomials today. So let's get started with this. Adding and subtracting polynomials and classifying polynomials is what I'm hoping that you'll be able to do by the end of this video. So what is a polynomial? A polynomial means many terms. So you've seen polynomials before. Here's a few examples. And what we're going to be doing is classifying them. Just like we would classify a dog using a species name, a genus name, family name, order name, and so on and so forth. There's different ways of classifying dogs, okay? Just like with polynomials, there are many ways of classifying. You can classify by how many terms there are or what their biggest exponent is, and that's what we're going to look at today. What I just named was the number of terms. I said that one. And also degree. I didn't say degree, didn't use that word, but that means the biggest exponent. So we're going to start with that one. The degree of a polynomial is determined by the variable with the highest power. If the term has more than one variable, then the powers are added together. So here's a couple examples. You've got the biggest exponent is 8. So that means it's a degree of 8. In this one, you have one term here, 13x to the 9th, y to the 7th. There's two variables. So what I do is I add those two together, get 16. So this is a degree 16 polynomial. Now we're going to look at some naming conventions. So if the degree is 0, basically, if there is no variable, it's called a constant. It looks like just a number. If the exponent is 1, the biggest exponent is 1, we call it linear. You'll look at that. It says 15x. You see that a lot. Quadratic is for 2. That's where the biggest exponent is 2. Biggest exponent 3, we call it cubic. Here's an example. Biggest exponent 4, we don't use this. The next ones we don't use as much. It's quartic. It's x to the 4th. Quintic. And 6 plus, we just say 6th degree, 7th degree, 8th degree, and so on. So in the previous slide, we had 8th degree. So in 16th degree, there's an example of a 6th degree polynomial. All right, so that's one way of classifying polynomials, is using one of those names. The other way is number of terms. I've kind of said the word terms a couple times. What's a term? A term is something that is separated by addition and subtraction. So terms they could be coefficients, they could be variables, they could be joined together, it could be both, but they are joined together by addition and subtraction signs. So in this first polynomial here, we have 2x to the 8th is one term, 24x to the 7th is 2, 9x to the 5th, 3, 31x to the 4th, 4, and 18 is 5 terms. The middle one there, 3x to the 18th, there's no plus, there's no minus. It's one term. Next one has 3 terms. So number of terms. Monomial, mono means 1, that's one term. So negative 2x to the 5th is an example. A binomial means 2 terms. 1 plus sign. Notice that a binomial has 1 plus or 1 minus, but there's 2 terms. A trinomial, 3 terms, has 2 signs, 1 minus, 1 plus. It could be 2 pluses, it could be 2 minuses. Okay. Anything with more than 3 terms is called a polynomial. And there's an example of that there. So that's the 2 ways we're going to name. Every polynomial we can give 2 names to at this point, a degree name and a number of term name. Let's do that a couple times. Standard form is when we write a number or write a polynomial in order from biggest exponent to smallest. So we take the whole term of 45x to the 5th and write it first. It's positive, so it stays positive. The next biggest exponent is the x to the 3rd. So I'm going to take that whole term and write it next. The next biggest is 1, negative 36x. And then negative 19 goes at the end. That's written in standard form. My leading coefficient is it's the coefficient in front, which is 45 here. My degree is 5, which means I call this a quintic polynomial. Okay, so how many terms does this have? You see 4. We use the terminology of 4 or more terms as a polynomial. So we would say this polynomial is classified as a quintic polynomial. Adding and subtracting polynomials. So if we add polynomials, all we're doing is we're adding like terms. Now, what makes something a like term? If it has the same exponent and variable. So 7x to the 3rd plus 4x to the 3rd. Those are like terms. All I do is add 7 plus 4 and say 11. The exponent does not change. If I have 7x to the 3rds and 4 more x to the 3rds, I have 11x to the thirds. 25x squared and negative 15x squared. Those add to 10x squared, positive 10. That's why it's plus 10x squared. Negative 13x, there's nothing else with just an x. So that gets dropped down right there by itself. And then 1 and negative 9 makes negative 8. Let's classify this. So it's got an exponent of 3, biggest exponent of 3, so it's cubic. It's got 4 terms, so it's a polynomial. So it's a cubic polynomial. Okay. What if we subtract? Subtracting is a little trickier because you've got that negative in there. That negative actually applies to everything in the second polynomial. It's like there's a negative 1 being distributed into the second polynomial. So 4x squared minus 5, nothing changes there. So I have negative 3x squared. Negative times negative is positive 2x, and negative times 6 is negative 6. Now I just combine like terms. So 4x squared minus 3x squared is 1x squared, or just x squared. 2x, there's no other x, so I'm just going to put 2x, and then negative 5 minus 6 is negative 11. Let's classify this. It's a quadratic because it's got a biggest exponent of 2, and it's got 3 terms, so it's a trinomial. So it's a quadratic trinomial. Okay. Know it was a lot of vocab and a lot of content there, but that's the end of lesson 1.